We've seen how to create classes and subclasses, and we've even seen how a subclass can call a method from its parent class. But we haven't yet seen how an instance of a subclass can refer to a variable in its parent class. It turns out this is super easy to do. To see how this might work, let's take our old friend the car. Here I've just boiled it down to the 5 variables we've been using, a constructor, and 5 of the methods. I've left out all the setters and getters. We've also seen how to create a subclass, in this case, moving car, and it has its own variables, its own constructor, and its own methods. There's a lot of stuff on this slide, so let's simplify it. First, I'll simplify the car, and we'll just retain the variables that are shared by every instance of this class. Now, let's simplify the subclass. And I'll smush everything together, but I will open up the definition for render. And of course, I'm leaving off all of the other methods. As we know, the first thing we do is we call super.render, and that calls the render routine in the superclass. When that comes back, you can see the first thing I do is I call fill, and I choose the color of the box that I want to draw on top of the car. Now here's the key thing. Where does box color come from? Well, if you look through moving car, you see we are defining it in moving car. So box color is an instance of every moving car. So there's nothing ambiguous about this. And of course, we saved box color when we called the moving car constructor. Now I'm going to take my moving car and do something a little bit silly. I want to change the height of the box on top of the car. The faster the car is going, the higher the box, like this. Here's our regular car, and here's our moving car. I'll turn off the regular car, and using the keyboard, I can slow down my car, and that makes the height of the box get smaller. If I speed up the car, the height of the box goes up. So this may seem a little bit silly, but this is what I want to do. So let's see how we can bring this about. In the hole that I left just before fill, I'm going to put in a new line. And I'll compute a new variable, which I'll call BH, which is simply the height of the box times the speed. And now I'll use this when I draw the box. But before we get into that, let's just look at the variables that are involved, box height and speed. First, where does box height come from? Well, if we look through moving car, we can see it is another one of the instance variables that got saved when we created a moving car. So okay, no problem. How about speed? If you look through the definition of moving car, there is no speed. It's just never even referred to. So where does it come from? Processing handles this just like a message. It looks at this and says, I'm a moving car and I need the value for my variable called speed. And it looks through moving car and it doesn't find one. So it looks at the parent class. And sure enough, there is a speed in car, and that is the value that gets used. This is another example of inheritance. The moving car inherits all of those variables from its parent. And it just refers to them by name. Since the name of the variable is speed, we just call it speed. So now we're set. We've computed our new variable BH, then we set the fill color, and now in rect, I'm using the box height to find the upper left corner of the box and how tall it should be. So instead of using box height, of course, I now want to use my new variable BH. And this is all it takes to bring about that change. The key thing I wanted to focus on here is where these variables come from. Let me show you one way to think about it so that you'll be able to keep all of this straight. So here's another version of our car and our moving car, and I've simplified things quite a bit. Our car just has 3 variables, a constructor, and 5 methods. Our moving car has its 2 variables, a constructor, and 3 methods. I just wanted to have more methods, so I made up another couple of imaginary methods for moving car, add box and remove box. When we create this subclass, moving car, and we say it extends car, conceptually, it inherits all of those variables from car. It's just as if we had done this. That's why we don't have to say super dot. They're part of us now, because that's what inheritance is all about. The same thing happens with the methods. And so the methods are also part of moving car, and we can just call them from within moving car. So if I'm inside of add box and I want the car to turn left, I just call turn left and it happens, even though turn left actually lives over in class car. Conceptually, because the moving car is a subclass, it has turn left and all of the other methods inside of it. I'm sure you've noticed that I've left one method behind in the class car, and that was render. Why did I do that? It's because we already have a render in moving car. It's at the bottom of the list here. So if I took the version of render that's in the class car and moved it into moving car, I'd have two routines called render, and processing would complain because it would never know which one we meant. You can't have two routines of the same name. So instead, and again, this is just conceptual, everything gets moved from the class into the subclass except for the things that have the very same name. Those get left behind. And if you want to refer to those methods that got left behind because they duplicate a name, then that's when we use the super construction. Now, if you want to avoid this problem altogether, you don't have to use the same name. The car version of render could have been render car, and the version in moving car we could have called render moving car, and there never would have been any confusion. But you'll find in practice that you often do reuse a few method names, just because they're the perfect name for the job. And you say, you know what, if this happens to duplicate the name in my superclass, that's no problem. If I ever really need to refer to the one in the superclass, I just precede it with super dot. It turns out that the very same discussion holds for variables. So if car had a variable called box height and moving car had a variable called box height, you could refer to the car version by saying super.box height. I recommend that you not do that. Until you're very comfortable with classes and subclasses, I strongly suggest you don't duplicate variable names. It's okay to reuse a few method names, because if you call the wrong one, you're likely to see the results pretty easily. Duplicating variable names, though, is much more risky, because you can very easily get confused and lose track of whether you're referring to the variable in your subclass or the variable in your superclass. And that can be a very time-consuming and painstaking bug to track down. I recommend that you make things easy on yourself. Never have a variable in your subclass with the same name as a variable in your superclass. If you keep this conceptual picture in mind, then it will be easy to remember that the only time you need to use super dot before the name of a variable or a method is when that variable or method's name is duplicated exactly in both the superclass and the subclass, and you want to refer to the one in your superclass. In all other circumstances, just treat your variables and methods as being part of your subclass, and everything will work out fine.